Welcome to fall. This is Oe and Sandy Math Along. I'm Sandy.
And I'm Oe.
Number 8, let the function f be defined by f of x equals 2x minus 4. What is the value of f of 4w minus 4 times fw? So this is a good one. I don't think we did anything in class where we actually multiplied the function by something from the outside. So this is a great example to look at before doing number 8. We have our original function, and here we are going to have an input of 4w. So first, let's input that 4w. Remember to use your parentheses always, okay? 2 times 4w is 8w minus 4. You can't simplify that any further, okay? That took care of this first part here. Now we're going to subtract 4fw. So I'm going to find 4 times fw. That would be 4 f of w. We're going to multiply 4 times, put a w anywhere you see an x. So 2 times w minus 4, and I will end those parentheses. So your f of w is 2w minus 4, and then the 4 on the outside of it is that 4 times f of w. So let's distribute over each term, and we get 8 w's minus 4 times negative 4, so minus 16. That's as far as you can take that one as well. Now, we are subtracting these two from each other. So we're going to take those two answers and subtract them. We get the 8w minus 4. I'm going to put parentheses around that, just so we have that quantity together, minus the quantity 8w minus 16. So again, that is our f of 4w minus 4 times fw. And you see they're not the same thing. They are different from one another. Okay, we have to distribute our negative sign. I need to start moving this board up so I don't have to bend over. And we have 8w minus 4 minus 8w plus 16. And at this point, we combine our like terms. So let's take all of our w's. I have 8w minus 8w, which gives me 0 w's. So those actually just become a 0. And then we have negative 4 plus 16. Negative 4 plus 16. I want to write that up here so you can just kind of see it. And I kind of ran out of room, so negative 4 plus 16 is equal to 12. And I didn't have a whole lot of room, but that is our 12. So f of 4w minus 4 times fw is equal to 12. Number 9, if f of x plus 3 equals x squared plus 6x plus 9, what is f of x? So this is kind of a reverse problem. Instead of being given f of x, we're given f of x plus 3, and we have to move backwards to see what would happen if our input becomes just x. Now, I do not mean to give you any kind of PTSD from algebra, but you're going to have to think back to factoring and foiling and all that kind of stuff, okay? We have a trinomial, and we know that a binomial has been inputted into that. So we're going to look to see if we can factor out x squared plus 6x plus 9 to get an x plus 3 out of it. Okay? Let me go through it. Maybe it'll make more sense once you see it. Okay? So we are going to factor x squared plus 6x plus 9. I want to at least get one x plus 3 to come out of that. Okay? So I know one of these needs to be x plus 3. And if you recall, you have to do the whole first, outer, inner, last to figure out where this came from. So if we multiplied our firsts, that's an x squared. Outer, we don't know yet. Inner, 3x. Last, we don't know yet. Okay? In order to get a 9 at the end, I'm going to put in a 3 because that will give me a 3 times 3 as our last term, which is 9. So now we just look at the sign in the middle. I'm going to go with the plus because the inner gives us 3x. If the outer also gives us 3x, that adds up to a 6x in our center. Okay, I'm really hoping you guys remember this. If not, I will have to do a reteach during class. But to put that another way, our first terms give us x squared, outer, inner, outer, inner, and last. Putting that together, we end up where we started. So hopefully that jogged a memory. And I'm going to erase it because now we just figured out how to factor this out. So we have figured out how to factor this into x plus 3, x plus 3. Remember, this was f of x plus 3 to begin with. So if we now input x instead of x plus 3, okay? So anywhere you see an x plus 3, you're going to replace it with an x. Well, I see an x plus 3 here. I'm going to replace that with an x. Substitution, use parentheses. And I see a second x plus 3, so I'm going to input x in its place. Simplifying that, it comes out as x times x. That's not 2 x's, okay? That's x times x, which gives us x squared. Remember rules of exponents. When you multiply, you add the exponent. We assume we have an exponent of 1 if it's just an x. So that becomes x squared. Our answer then for this problem is x squared. So on your problem, you start with a different trinomial. On yours, I believe it is x plus 2 that you want to look at. It is a very similar process. So get to it. Ask me in class if you have any questions or leave a comment below. Number 11, function h is defined by h of ABC equals 6a squared b cubed minus 3ac squared. What is h of 1, -2, -3? So let's get to it. I always like to rewrite it. And you know what? I'm going to change colors to make it a little bit less confusing. So we have H of ABC. It's kind of like what one we did in class as an example from the book. 6a squared b cubed minus 3ac squared. We want to know H of 1, -2, -3. So when you have multiple inputs, they will give them to you in the same order, okay, as how they're labeled. All right, the same order in both. So ABC, 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 ABC. That means A is equal to 1, B is -2, and C is -3. Okay? So all we have to do is plug in or substitute in our values for A, B, and C. Always use your parentheses. Okay, so what I did is I made my parentheses first. I have 6a squared b cubed minus 3ac squared. Let's plug in. A is 1. So A is a 1. A is a 1. B is a -2. I have a B here. I'm going to put in -2. And I have a C is -3. Now, lately, my biggest source of anxiety in every one of my class sections, I love you all, is figuring out these exponents. Y'all got to work on these squares, cubes, etc., and make sure you're squaring and cubing the correct thing and multiplying it by itself and multiplying it by the exponent. I'm going to have Owen do a whole video on exponents, just him, the camera, the board, and I'm just going to let him go. I'm doing it. We'll do it Saturday or Sunday if I take him to a theme park. Anyway, I digress. So now we need to simplify this, okay? Remember order of operations, okay? PEMDAS. I'm going to go to my brown marker for PEMDAS. Parentheses. I don't have anything in my parentheses that can be simplified. They're just numbers. So PEMDAS, PE, exponents. We have plenty of exponents to work with right now. So let's see here. We're going to bring the 6 because it doesn't have an exponent. 1 squared. Come on, guys. That's a freebie. -2 cubed. -2, -2, -2. So -2 and -2 is 4 times -2 is -8. Minus, we're going to bring down that 3. There's no exponent there. No exponent with the 1. Now we have an exponent, -3. -3 times -3 makes +9. Okay? No more exponents, so we're good there. Oh, that's cool. My area code back home is 618. I didn't do that on purpose at all. I don't know what 319 is. Okay. Next, in PEMDAS, we are going to multiply and divide. We have plenty of multiplication here. No division. Okay, but we're going to multiply. 6 times 1 is 6 times -8 is -48 minus, we have a minus sign. 3 times 1 is 3 times 9 is 27. Okay? So we didn't have division, but we did have multiplication, so we can check that off. Next is addition and subtraction, PEMDAS. We don't have addition here. We have a negative number minus another number. So we definitely have subtraction. 48 minus 27 is going to be 75, and that is a negative 75. So we did our order of operations in order. We got negative 75 as our answer. Number 12 is a lot like the example from the study guide that we did in class. In the standard XY coordinate plane, a transformation maps the point XY, and I am making this up as I go because I don't want to give you the exact same thing as in the book. To its image, I'm going to say 3x plus 2, comma, y plus 4. Okay? I need to get that 12 out of the way there. All right, so this is how I'm going to map mine. The transformation maps, I'm going to say 3, negative 4 to what? Okay, this is a little easier actually than the example that we did, because in this example, you are just going to put your input into the function, okay, so to speak, into the transformation, which is a function essentially. So we don't have to go through the steps like we did in class of figuring out what that transformation is first. So simply, for every x, we're going to put a 3, and for every y, we are going to put a negative 4. So 3 times x, use your parentheses to plug in your 3, plus 2. Can you guys see that? I never leave enough room, but I think the camera picks it up pretty well. All right, and then we have for y, instead of y, we're going to write negative 4, and then we're going to bring down 4. Okay, so now we just need to simplify this. Once we simplify it, we will have our answer. So again, remember, PEMDAS. I mean, we have a lot of parentheses going on here, right? In these, in particular parentheses, we can't do anything. So we're going to go to exponents. We don't have any. Multiply. So 3 times 3 is 9 plus 2. Negative 4 is just negative 4. There's nothing being multiplied by it or divided. Plus 4. Now we go to add, subtract. So 9 plus 2 is 11. Negative 4 plus 4 is 0. The new point after the transformation is 11, 0. That's it. It's actually pretty easy. If you don't like squishing this all together, you could kind of come to the side and just do your x and then do your y down here. So if that works for you better, you could say, all right, we're going to just work with the x. So instead of 3x plus 2, I have 3 times 3 plus 2. Which is 11, and then say, okay, let's do our y separately. So we got our 11. We're going to do y plus 4, but I'm going to plug in my negative 4. Plus 4 is 0, at which point you put them together. Same answer. Whichever way works better for you. I know it gets confusing when you do 2 equations at once, but my brain just kind of goes that direction. If yours doesn't, this is quite valid, okay? Number 13. The last question on these is always a good one. Here's this week's last question. F of x equals the square root of x. G of x equals 2x plus b. If the graph of y equals f of g of x passes through for 2 in the standard XY coordinate plane. What is the value of B? Okay, so we have, first of all, a compound function, f of g of x. So my first step is I'm going to figure out what is f of g of x. Okay? I'm going to erase this part of the problem in order to do that. I'm going to write for 2 up here in the corner, so we remember that point it passes through. F of g of x. So we are going to take our middle function, okay, as our input. So 2x plus b is our input, okay, and we're putting it into f, okay? I said that funny, but we're going to put our input into f. So we have f of 2x plus b, I know it's a lot of letters, equals the square root of x, which is our input. Use your parentheses, 2x plus b. Okay? So the graph of the function that we're looking at is the square root of 2x plus b. I know you guys don't know what it looks like. I told you in class, I know exactly what it looks like. I read it just like you read a book, and I can see it. All right, but let's get you to see it. Remember, f of 2x plus b, we can look at this like it is our output. In the 4, 2 that it gave us, our output is our y, of course. And our input is the 4, that's our x, okay, our x value. So 2 times x plus b, and we have the square root of that whole thing, okay? Let's simplify, and I don't know how this is going to work out exactly because I just made it up. 2 times 4 is 8 plus b. We cannot combine 8 and b. Don't tell me it is 8 b's because it is not. They're not like terms. I have 1 b and I have 8 sticks, okay? Can't put them together. So I want to get b out from under that radical. Goal is to get b by itself somewhere. I'm going to square both sides to get rid of the radical. 2 squared is 4. The radical went away because we squared it, so we have 8 plus b. And I want to solve for b. It's being added to 8, so I'm going to subtract that 8. And I get negative 4. I'm getting low here. Equals, those cancel, b. It's hard to write down there, okay? So the question asked, what is b? We got it, just to write it a little higher, b is negative 4.